Welcome, Smashing members. We have Vitaly here, Mr. Smashing Magazine himself, and Maxim Salnikov for part 2 of the PWA webinar series. In Maxim, we've already asked you a few questions. Vitaly tried to make you say some bold statements, but there's one important question that I'm not sure if we asked you last time or not, but it is very important to the Smashing community, and that is, do you like cats or dogs better?
Cats. I have the one, maybe he will come to us later. He's cute, but very noisy. Maybe we have to keep them in a different room for the session.
Okay, we'll be looking out for that.
So just to let everybody know, we are recording this, so if you have to leave early, it'll be available on the Smashing membership page once we upload it after, as well as be available on the YouTube channel, and we're actually streaming live on Facebook.
I hope. Yeah, we clicked all the buttons, so let's see if we actually did what it's supposed to do.
So on that note, I'm going to hand this over to Vitaly and Maxim, and then I'm going to go to another room and check my phone to make sure it's streaming on Facebook.
Yeah, but we'll be missing your wallpaper and stuff, but that's okay. All right.
I'll be right back.
Okay, thank you, Scott. So yeah, I just wanted to briefly let it go and leave it out to Maxim to kind of explore the shiny new world of progressive web apps and how we can build things for production. Personally, I wanted to welcome everyone who is joining us today, who'll be also watching later. We're kind of trying to bring as many practical insights into this shiny new world of Smashing TV. So if there are any particular topics that you're interested in, just let us know and we'll bring it up. I'll also be kind of asking and raising questions in the end of the session. So if there is something that bothers you or some particular things that you really want to find out, just type it in the chat and I'm going to bring them up. Okay. With this in mind, Maxim, are you ready?
Ready.
All right. So let's bring it on. So please give a warm hand to Maxim by saying hello, Maxim, in the chat. That would be very nice. I'm muting myself. Maxim, over to you.
Hello, dear developers. Yes, my name is Maxim, and we start chapter 2 of 3-chapter series PWA for production. Before we start, this might be very useful for you to follow this slide deck, and you'll find the link to this one and to previous and in some future time point for the next one on this link. This might work for you well because there are some code samples, lots of useful links, so just follow me. This is, say, mix of presentation and hands-on. This is quite unique format of this webinar. So you might want to follow some practical exercises. It's fully up to you. But if you wish, I think you have pretty much everything ready to go for this. You decide. Maybe that makes sense for you for now and for this for next hour, just to watch and listen and try to do something hands-on later. Fully up to you. If you wish, I can give you all the guidance, and we start like this. So I have repo called PWA for production on my GitHub account. If you go and clone this, and if you install simple static web server called Surf, you are fully covered. So you don't need any other tools. We start from this branch, from part 1, because last time we started from part 1 init and came to part 1. So this is basically final destination of part 1. If you wish to jump straight ahead to our final destination for today, it's called part 2. So this is where this is our way for today. We go from part 1 to part 2, and from completed part 1 to completed part 2. What kind of application we have today? It looks something like this. So this is, say, super simple, super tiny Twitter client. And from Twitter, we have only basically some timelines loaded for us. This app built on Angular framework, but you don't have to touch Angular at all. I have like the production build ready for us, and we will work only with what we have in dist folder. So no Angular like code components, no Angular workflow at all. So we work with, say, pretty generic JavaScript or front-end application, any framework or without framework at all. Good. So no knowledge of Angular is required at all. So we go from part 1 to part 2. Just 30 seconds about me. I do lots of activities around progressive web apps. I organize meetups. I run PWA Slack, and I hope to see you as a member of this Slack after this webinar, and I will share the link later on Twitter, and maybe dear organizers will do it also. My Twitter is webmaxru. I tweet mostly about web platform, about latest and greatest stuff from web APIs, from progressive web apps, service worker, all that stuff. So if you wish to follow this stream of news, please follow me. What are we going to do today? If you attended our last meeting, our part 1, it's great. If not, no worries. I'll try to give all the context, to give the short recap, what we've done and what we want to do. Last time, we created very simple, I'd say naive, progressive web application, but the main important point was we created everything by our hands. By everything, I mean service worker. And we'll start from this point. So I will show you the final destination of part 1, this handmade service worker, and you will see so how much code is there, and I will list all the points why it's not very good option, at least for the beginning. So during next 51 minutes and some extra minutes for the questions, we'll try to say really prepare this for the production and to cover some edge cases, to cover some scenarios, and we'll add more and more things. So this chapter is fully dedicated to offline and to network optimization. We go way beyond of this area of progressive web apps on our final part 3. We'll have a look on what's ever possible except all this offline and network magic. But today is Workbox, today is networking. Good. And now promised short recap what is PWA at all and what we've done last time. It's checklist of this form. I compiled this from some other checklists available on the network. So basically 4 main points. Web application manifest. We jumped into details on the previous meeting. It's all how to make the application installable. What do we have to provide for this? This is not on our agenda for today. Application shell is how to make application UI available offline. Okay, we have this covered by our manual service worker, but we'll check how it's possible to do it in automated way. Last 2 points, I hope we all do 100% of our front-end applications like this. So it's not related to PWA at all, really, right? We don't want to build slow and mobile unfriendly apps and serve this via HTTP. It's not the case nowadays. Good. And we'll start from the application shell. How do we provide offline experience for literally, say, for the UI frame of our application, for our application itself? So at this time point, we are not talking yet about the data which is our application consuming. To build this, let's briefly architect what will this take. So just imagine the web, the current state of web is fully ready for this kind of user experience. And yes, of course, so we have the browser. It includes JavaScript engine. We can download and cache all the assets we need for this application, like HTML, JavaScript, CSS. Why do we have to care about connection status at all? I don't know, and the service worker gives the answer on this. How to make this happen. So first, it all starts with what exactly constructs our application shell. And here on the left-hand side, you see that just an example, what could be included? Maybe a header with menu, maybe some navigation icons, maybe some placeholders for the data. This is not the data itself, but you know, this is pretty a common scenario when we have some placeholders where we load the data later. Okay, we defined what we want to have as an application shell, and maybe I can even show you how that might look. So back to our application. We have dist folder, and this is what Angular CLI built for us. But again, don't mind about Angular at all. This is some set of files we have as application shell component. So obviously index, obviously main JavaScript bundle, maybe some extra like utility bundles, CSS. Okay, now we have this list in mind, and if we jump to our handmade service worker, of course, we have to list this somehow, right? And again, this is quite naive implementation. Maybe these files will contain hash as a part of this name, so we have to care about this list all the time basically on every application build, and of course we want to avoid this manual job. Good. Next, what happens on the first application load? We have to take all these resources we mentally prepared, and put it into some storage. And this is not old gold HTTP cache at all. This is something totally new, like relatively new, of course, called cache storage. And this is very specific storage where we basically store the payer's request response. So it's a storage specifically like created and existing in browsers for this kind of caching. Luckily, all evergreen browsers, they have this storage and corresponding API. Then on all next application loads, we can just grab the data, these resources from this storage instead of going to network, or at least before even trying to go to network. And it's up to us, how do we implement all the strategies? Do we try only cache? Maybe it's not very future thinking, or we try cache first and then go to network, or we can go to network first. Like all the strategies are for us. But also, we don't want to always serve very initial version of the application, which was pre-cached on the very first application start, right? So this is why we have to think something about versioning. And again, if we go back to our implementation, we do it pretty straightforward. Every application build, we have to manually change the version of the our storage box, and then on one of events of service worker called activate, we clean the cache, and so we always iterate full cache every change in our application. Maybe this is not optimal, but we'll see how to fix that. Nice. And a couple more minutes to give you context what is service worker at all. So you already have seen the code, and you may notice that basically most of the code wrapped into some form of event listeners, right? So this one called install, this one called fetch. Like we don't care for now what do they mean. Yes, basically only some definitions are not part of these listeners, which comes to the conclusion. It's event-driven worker, right? So all the code fired on some form of event for this file. What kind of event? First, maybe the main one, and the definitely main one when we are talking about some form of serving offline data, called fetch. And this is what, say, our application sent to service worker, or even more general browser sent. For example, when you just type something in the URL bar and there is a service worker attached to this origin, this is not yet your application sends this event. This is a browser itself, because application is not loaded yet, right? Okay, and on receiving this event, we are free to decide what to do. We can go to network, or we can go to cache to try to get these resources from there, if we, of course, previously put it there. Another example of event service worker can get is sync, and it goes exclusively from the browser. So application knows nothing about when we switch from offline to online mode. So this is very important event. And another example of event which is going straight from the cloud to the service worker, again, our application is not taking part in this flow at all, is about push notifications. Of course, it goes straight from the network. Nice. So we have an application, we have service worker, which is, after all, JavaScript code in form of JavaScript file or some set of files, some form of modularization is possible. Okay, let's go forward. If you remember last time, and we did handmade, and instead of these slides, maybe I'll better show you the code itself. So on installation, we manually use cache's interface, which is API for this cache storage, and we put all these files we prepared here in this array there. On the activation, we check that if we have some cache storage, we can think about this like about table in database. So if we have tables with older names which are not version we have now, we want to put into cache now, we have to remove this. We have to do this all manually, and the code is not that long, but believe me, this is very simplified and naive version. So this will work for, say, the best ever scenario. So last time we created workable, like fully working app, but like very limited to some again best case scenarios. This is why in the real world we have lots of things to care about in addition to what we created. So first, HTTP protocol is not the simplest one, containing lots of different modes. Plus, you remember that every time wiping the whole cache, even if we change only one single file like index.html, maybe this is not optimal, and we have to come up with some idea how to invalidate cache if we want to do it like in the more optimal way. Okay, next we want to, after all, serve this data from cache, right? And you remember we have an event called fetch. Again, let me jump straight to the code to show you how that looks in the manual written service worker. Again, this code is working, and it even contains some form of routing. You see, again, very naive. We just check, okay, if there is a timeline in request URL, we go for this strategy. We have to implement this. If not, we go for this if not this URL, but that URL, like something that we load from Google CDNs, and in this case, this is fonts, icon fonts. We go for this strategy. Again, we implement this manually. Otherwise, we go for this strategy, and this is basically application shell. This is, say, the most conservative one when we try to always trigger cache, and we do not even try to update this cache for now. Even for quite simple scenario, we have this amount of code, and again, believe me, this is code not ready for some maybe some non-regular use cases, and you see the routing is not scalable at all. I'd say we don't want to have more and more ifs. Possible to implement everything manually, but maybe we can automate this. And instead of implementing these strategies, and instead of thinking about all these possible complexities and about other possible strategies, maybe we can find some good tools. And I already have shown you this slide. Today we are working with Workbox. So this webinar is dedicated how to quick start or to convert your manual service worker to the one extended by Workbox. So first of all, it contains really great set of functionality straight out of the box, and for majority of these functions, we don't write the code. It's formally JavaScript code, so it's not like, for example, JSON configuration, but this is the code which is basically just providing the configuration. So you will see what I mean. The main benefit, at least for me and for many developers I communicated with, is the possibility to keep our own service worker. So we have full control on the service worker. We just extend it by this or that piece of Workbox. And we are just a couple of minutes away from starting our practical things. And before we dive into, let me list working modes. First, we can install Workbox CLI. I'm not a big fan of CLIs for every big and small library, and maybe this is not super friendly for CI/CD. If you use Webpack in your project, Webpack plugin is definitely a very good option for you, but for the most general case, node module is the best, and we start with this. So if you follow me by on your code, I hope you already cloned the application and switched to proper branch, which is part1, and now you might want to install package called Workbox build. I already did this, so I will save some time, and we will use this package only in the build mode, so you can safely put it into development dependencies. What's next? Next, we have to explain to Workbox where to grab the files we want to have as a part of our application shell. So you remember that instead of having this manually, we can keep this option, of course, but maybe, again, this is not a very future-looking option, because we build our application many times a day, and we might have totally different sets of the files. So it's better to have some form of patterns or wildcards, and we'll go for this option. So we explain to Workbox where to grab this via this configuration. It's our next slide. And we will use inject manifest mode from Workbox build. Basically, this is the call of this method using this configuration. Inject what and where. First, let's have a look how this configuration might look like. So all the basics, and instead of specific list of these resources, we just provide patterns, or we always can have this very specific list, but believe me, in your real life scenario, you go for patterns. And we have this very important option called source service worker, and this is basically our one. We have this as a source, and then we build this and put it to our distribution folder. You'll see what I mean on practice in just a couple of seconds. And then our service worker could look literally like two liners for the application shell, at least, because this magic method called precache and route will do all this dirty job for us. Basically, pretty much everything that we have here and way more. Let me close everything that I don't need now, not to intercept us. Good, let's start. Let's start with creating our, let's start with source service worker. And it's not here. And since this is something that we are going to modify, it makes sense to put it into source folder of your application. Again, this is just for Angular, this structure. Don't care about this at all. This should be just source code folder of your favorite framework or framework without framework at all. Let's call this file like this, and of course I have some snippets to save the time. You remember that for the basic scenario we have the source service worker as simple as this. For the beginning, we will download Workbox library from CDN, from Google CDN. We'll change this later if time allows, but this is pretty workable. The working scenario, of course, it's quite challenging to test this offline, but we can start like this. Also, I want to give the maximum ever debugging level. So we'll get lots of messages in our console log to check what's going on. And then this magic method called precache and route with empty array. And of course, this is not the case for the real service worker, because Workbox has to know where to grab these files, right? Okay, and we cannot use this service worker again as a real service worker, right? We have to build this injection script, and let's call this Workbox build inject, and this is the script for Node.js. So this is not for our application, and yes. Of course, it should not live in source folder. It makes sense to put it into root. And snippet for this, as you have seen on the slides, could be following. Let's have a look what's going on here. Yes, we use a method called inject manifest from the package I already installed. We provide patterns, so you see, I don't care how many JavaScripts I have, it's very handy. This is where we refer to this freshly created service worker Workbox JS as a source, and we put everything to our destination folder, which is distribution folder. Well, I hope we are fully ready to start to run this script to get our production service worker. And let me switch to the terminal. Sorry. Workbox build inject. Yes, something happened, and it even gave us some form of report. 15 files will be pre-cached, and the total size of this. And if we check distribution folder again, we see, okay, SW Workbox is here, and how it's different from this one. Easy. We populated this array with the real files we have, plus we have hash sums of these assets. Okay. What else? What do we need to start the application to make it driven by this Workbox service worker? Of course, we have to register, and this is index.html from our last step. Sorry, from our previous chapter, and you see what we have to switch here from this service worker. We can even delete this, so we don't need this manual anymore. Handmade, farewell, handmade, SW Workbox. Okay. Save, and let's switch to our application. And I encourage you, if you do something together with me, keep this the layout like this. Put the small part for your application itself, because we don't care so much about this. But we care about debugging and testing. And this is where we have all the details about our service worker and about our cache. Clear storage. We will use this many times today, and we'll use clear site data many times today because our application will start a new life. This is not the case for production mode. Of course, we don't have to ask our all our users to go and clean all this. No, but for the development, this is very important. Okay, let's try to refresh. Looks good. If we check the network, is no, something went wrong. We still refer to this handmade. What was the issue? Yeah, for some reason, the data clearance is not always working. So this is definitely bug of DevTools. So you see, even after I hit clear site data, some leftovers are still there. Let's maybe, you know what? Maybe I changed this name in the wrong folder. Or okay, let me do it like this. So we have source folder, and we want to. I think I forgot to rebuild the app after I rebuild service worker after I changed this, and this is why newer index.html not landed in the proper place. Or I can just restart the browser. That might also be the issue. At least let me close this tab and let me open this again. And let me open DevTools. Okay, that looks better. Let's check all. SW Workbox JS. Yes, this is proper one. And if you check application, service worker. Yes. So we just connected, we just registered a freshly built service worker against this origin. What can we do now? We can check if this really works. How to check this? We go and click offline, force disconnected from network. And by the way, I strongly recommend you to keep this disable cache checkbox always on when you do some development. Believe me, this will save lots of time for you. And it's really important to understand that this cache is not about this cache storage, which we use for our progressive apps. Though this is about old gold HTTP cache. So we better not touch this at all today, at least for debugging. Okay, offline, and let's hit refresh. Magic, everything is working. Everything except some assets of the application, in particular font icons, we load from the network. Maybe this is a bit, say, synthetic example, because if, for example, these icons are part of your application shell, it really makes sense to host them locally. But for our purposes, to showcase the next step, this is a very good option. And by the way, let me give you some more hints on how to test everything. So first, you might see some icons, this cog, and that means that this request is going from service worker, or it relates to service worker itself. And we can showcase this by starting from scratch. So clear site data. I hope this time this will really clear everything. We have to go back to online. I just want to show you one thing. And let's clear this tab. Let's have a look. You see that here we have regular download of all the application assets, right? Next, we register service worker. Okay, got it. And then service worker does basically the same what main thread does. It downloads all the files. Why? To put them into cache storage for the future use. So important thing to understand, on the very first load, your user, your client, will get downloaded basically two versions of your application shell. One is to render something immediately in the browser, and the second to cache. And it's technically not possible to, say, reuse these assets in service worker, not to do double download, but this is how that works. One of say compromise or drawbacks. But if we keep the application shell as lean, as small as possible, it's not a big issue. Okay, so it looks like we have the application shell ready, almost ready, because we have to fix one small thing about these icons. Good. And just as some recap, this is what we exactly inject into our service worker. I can show you again. This is source one with empty array. What Workbox script does, what this Workbox build inject does, this is basically generates this list and do file operation. It injects this array here. That's it. No more, no less. And the rest of the magic, I always call this method the magic one, is here: pre-cache and route. All the hassle related to pre-caching, to managing versions, to serving, all is here. Good. Let's move forward. We have some more things to do. And yes, of course, we might want to add this Workbox service worker build script as a part of our overall build. Just not forget to put it after your main application build. But in our case, I will just do this manual run every time, not to over complexify things. Nice. Coding time, we just did everything. So we are good to go to the next chapter. Is about data our application is consuming. So now we are good to go with application shell. So this is pretty much static version of our JavaScript, of our front-end application. But of course, we might want to go further and do something with the data we download from the network. And in my sample, these are tweets from my timeline and tweets I favorited. And you see, I favorite tweet from Smashing magazine, which is about exactly this seminar. And it uses simple Node.js API, which is using Twitter API. I also created this, and it's also available open source. So if you wish to run this backend locally, fully up to you. You can run this. You can experiment with this. Okay, if you remember how it was done in our manual way, it's a bit different code, but showing the idea. So we check if the URL is like this, we implement one strategy. If URL is like this, we implement another strategies. And of course, you see, it's not very scalable. It's not very future-proof. And I'm even not saying about the fact we have to implement all these strategies, right? So you remember we have some code for very basic implementation, which is not taking care about lots of things that might happen. So. And we definitely don't want to make even more ifs like this. What Workbox offers us in that sense? It sort of returns declarativeness. So a brief jump into the history of all this offline possibilities of the web. Service worker and progressive web apps in general is not the first try to have this functionality for the web. And one of the first, say, APIs and more or less web standards-based APIs called app cache or application cache. And it was very unfriendly for developers to use. It was very limited in use cases to apply for. Why? Because it introduced a declarative way of caching assets. So basically, we sort of provided description how we want to cache this, for example, index HTML, or how we want to cache this this resource, this PNG or whatever. And the practice confirmed that it's not the best way. It's the declarative could be really good for some parts of our JavaScript application, but not for caching. In cache, when it comes to caching and managing cache, we have to be very imperative. So we literally have to say, hey, service worker or cache API, take this resource and put it into cache. And you have to remove this. And if something happens like this condition, remove this from the cache. So we have to give orders. And of course, this is very, say, code-heavy way, all the imperative stuff. So what Workbox does, it sort of return declarativeness for simple use cases. So you see, despite this is not say JSON configuration, this is JavaScript configuration. It's hard to call this coding, right? It's still providing a configuration. So hey Workbox, for this set of URLs like API breaking news, please introduce network first strategy. Okay, very declarative, right? But it gives us possibility, it keeps this door open to write our own code if needed. So if we really want to have some complex logic in caching this or that resource, we can go for plugins. And first, Workbox equipped with 5 strategies, and they are, say, production ready. Believe me, they contain all possible fallbacks. They think about some, say, non-regular scenarios, and it's absolutely ready to go for your production app. And plugins. In form of plugins, we fine-tune some options, like when this cache expired, should we inform our application about something was updated in the cache? But the super possibility is to write our own one. So if we really need some custom logic, and believe me, in some project you do, we can just provide this in the form of our own code. So let's check how that works, if that works, and how complex is that. We go back to our source service worker, so it's important for me not to mess up this. So this is our source one, which is, in our case, it differs from the one we built only by the presence of this array of resources. And we can provide some runtime caching. And my next snippet is here. Bam. Let's see, and all this code is available in part 2 branch. So if you wish to follow me, just copy from there. You will have your own snippets. So what's going on here? First, we decided, you remember that we want to fix the application shell completely, and we want to have these icons. This is why we go for Google CDNs, where this hosted. We can provide the name for this cache. You will see where it's used. We can provide the strategy, which is stale while revalidate. That means that we try to download something from, not to download, but grab something from cache, and at the same time we send request to the network if that was updated. Maybe that's not like real case for web icons. Maybe they are not so often updated, but to demonstrate how that works, this is quite nice. And in form of plugin, I decided to limit number of entries in this cache. Okay, 30 is enough. For other routes, first I decided to show different ways we provide this route. So here we can use new regex, and here is a bit different syntax, about more or less the same. So for the timeline, we go for network first strategy. For the favorites, we go for cache first. Nice. Let me save this and let me build our service worker again. Well, it's a bit overkill to do build, even if we know that nothing changed in the application shell files, but it's a good habit. Let's have it like this, because we will need this later. Okay, let's switch back to our super application. To avoid all this hassle with open, closing tabs to make sure that the application was updated, we do this hack. Again, this is not the case. You don't have to ask your users to do all this cleaning. It's our next chapter. We are covered. Now, reload the page. And if we switch to network tab, let's clean everything just to make sure that everything is working like we need, like we want. Runtime caching. Let's try to grab timeline and favorites. It's not very good what I see here because service worker, it looks like it didn't intercept this calls. For which reason, I don't know. Let's check if we have the one we need at all. Okay, that looks correct. This is a bit strange then. Let's give it a try one more time. Okay, yes, now that's correct. So you see that our application requested this, and service worker in its turn also requested this, because this request was intercepted by service worker, and the actual call to the API, to this remote API, was made by service worker, but not by the application. And same for favorites. Why it downloads this font every time? Maybe because it contains this icons from this material design font, and we disable the cache. Okay, it's not a big deal. Now I think we are ready to move offline. So now just imagine our customers, they started our application for the first time, and then they go to, I don't know, to plane, to some tunnel without internet, to like prove that there is no internet for this tab. I can even shut down the server. I can even shut down surf, but let's just not spend time. Just trust me that now for this tab there is no internet available, and of course both internet and even localhost connection. So like it's fully offline mode. What we can do, we can hit reload. Okay, looks very good because application itself is available and icons are available, and don't care about these red lines. This is service worker which is trying to reach the network, and of course it fails. We see that this is service worker because the icon, you see, that means that this request was made by service worker. And why does it try? Because of the strategy, because of strategy called stale while revalidate. So it still tries to ping the network. But let's go here. Let's load. Let's clean this first. Let's load the timeline. Nice, it's here. And again, you see request from our application went to service worker. Went to service worker, and service worker delivered the data. This data delivered from cache storage by service worker from us, for us. And here we can check how that looks. Workbox runtime. So we see basically this is JSON which was pre-cached during the first trigger of this API endpoint. Let's switch back to network and let's try to load favorites. You see the difference, right? For the timeline, we decided to go for network first. For favorites, we go for cache first. That means if favorites found by service worker in storage, we don't even go to the network. This is why we don't have corresponding favorites request, which obviously will fail. So we are fully satisfied with what we have in cache. If we change the strategy to network first, here for favorites, we'll have absolutely the same picture. We will serve the data from cache storage, but at the same time, we'll try to go to network. Okay, let's move on. So what we have now, just a short recap. We have application shell ready, and we have runtime caching ready. Nice. You remember, I told you we might need some mechanism to provide versioning. We don't want to always have the previous version of application always running, like not previous, but the very first one, right? And we can see something like this. We deployed version 1, and on the first load, we will have this version up and running, right? Then just imagine that we changed something, and there is version 2. What will happen on redeploy and reload? We will still have version 1. Why? Because Workbox will grab the data from cache storage, and this is exactly what we expect from this library, and even from our manually written service worker. If this is the case, this is how offline mode works. So we don't go to network first. We try to grab data from our local storage, and don't be confused. I just used a wrong term. This is not API and the storage called local storage. So we are not talking about this. I mean local cache storage. So these are very, very, very different things. Nice. How do we fix this? Basically, we don't have to fix this because on the next load, we'll get version 2. Why? Workbox will compare the version. How will this be compared? Very easily, because we provide all the tools for this, provide in the form of hash sums. This is Workbox build library built for us, and this is Workbox service worker we'll use to say smartly update the contents of cache. So this will not wipe all previous cache and populate with new files. No, this will update only the files needed to be updated. So if we changed only index.html, of course, Workbox will update only this one. But maybe we want to give some form of hint here, right? Something like this. And I bet you have seen this UX prompt, this dialogue, or maybe some form of alert on many websites. What does it mean? That means that first, this is a website driven by service worker. Second, you visited this site before. And third, before your previous visit and current visit, something was updated, and service worker understands this, and you are free to decide. You might want to refresh this now, you might want to postpone this, you might want to never refresh this. And for example, just imagine you started to fill some long form, I don't know, your account stuff, and there is a prompt. Do you want to refresh? Of course, no, because we will lose all our work. So maybe we want to postpone this. So this is just a hint that despite at this moment, instead of showing this message, we technically easily can force reload the page. Please don't do this. Please give the choice for the user. How can we use Workbox power to implement this? Option number 1. You remember that Workbox is everything about plugins, and we already use plugins in runtime caching. Same we can do with pre-caching, with files we have as an application shell contents. Plugin called broadcast update, we just have to provide some form of name. Why? Because we want to listen to the channel with this name in our main JavaScript code. It's absolutely working scenario, and maybe this is the simplest option ever. But this time I decided to go a bit different way. Workbox is providing many options to achieve the same in many cases, and I really love this flexibility. We can rely on service worker life cycle. Maybe it's a good time for us to return to the registration code. How do we exactly say that this application, or to be precise, this origin, has to be connected with this JavaScript file, which will be service worker for this origin? We have to provide this code for the registration. This is maybe the simplest one, and this is absolutely vanilla JavaScript code. Let's have some requirements. How to make this process good and like good enough, let's say like this. First, we do feature detection, and you see that we are here. Yes, we check if this browser is capable of service worker API at all. This is absolutely must have. Never try to register service worker without this if, because this will break progressive enhancement idea completely. Then we want service worker to do all the job only after all main assets loaded by main thread. And we achieve this by adding this listener. Nice, pretty simple, also not something not to forget. But then we can check some lifecycle events of the service worker. So last time we slightly touched the lifecycle of service worker. It's very specific, very strict. And some of these events will help us to understand, was service worker updated at all? Nice. And if service worker file, this SW workbox or whatever JS was physically updated, does this mean that app was updated? Or let's ask it differently. If the application itself, like application shell, was updated, will this cause the service worker file to be updated? In our case, yes. Why? Again, go back to how that looks, not source, but build one, because of this. So new main.js, new revision, new physically different SW workbox.js. So we can definitely say if application was updated, then the service worker file was also updated. And of course, if we updated service worker itself, add I don't know, some features and I don't know, fine-tune something to a greater extent, that means that application itself was updated. I mean, not application files, but application behavior. So we can definitely think that yes, this is the next version of the application. Okay, how do we use this? There is a new module appeared in Workbox version 4, maybe some like month ago, called Workbox Window. And this is the first module which is fully dedicated to window context. So it's not for service worker, it's for our application. And then in our code, we can register service worker, not using like plain JavaScript, but using some shortcuts, some syntax sugar from this module. This gives us access to some useful listeners. But you see that if we go this way, this will require, again, rebuilding the application, and we don't want to deal with this. So we want to skip, say, like Angular story or React story or Vue story of the application completely. This is why there is alternative to do this. We can do everything like super directly, super like straightforward. We can even download this from CDN again, if we just provide type module for the script. And let me do the same, but let's go back to the listeners. You remember, our goal is not just to use this syntax sugar by registration. We want to hook into some events. And the one we need called installed. And if there is isUpdate equals true in the parameter we receive as a parameter, we can definitely say that there is a new version available, and it's up to us. We can ignore this, we can show some prompt, and on the very first load, we also might want to show the message that application is all offline ready now. It's, again, absolutely up to you. Using this method, we have to fine-tune lifecycle a bit just to make sure that on refresh, this will be really refreshed. And some other useful events are listed for you, okay? And our last coding block, maybe our last 3-5 minutes, and last snippet for you. Okay, so let's change the registration code in our index.html, which is in distribution folder, and then we have to demo how that works. I will explain you. Instead of, say, regular registration, we go for Workbox one. And since, say, maybe not all the browsers and definitely not all the versions support this JavaScript standard-based import, of course, this code is more for, say, just to showcase the idea. Maybe you still want to use more regular way. You might want to import this library in your application code and then do all the needed bundling and transpiling and whatever. So maybe this code is a bit too early to use in production. And to fine-tune the lifecycle, we go for this piece of code, and let's save this. And our source service worker. So we just say that new service worker should take control immediately, even though if we have even if we have some tabs open with the same service worker running. Now we reveal this. Okay, let's just check if everything is looking good in our destination service worker. Yes, it's nice. And then we can switch back to our super complex application. Let's, of course, we have to return to online. We might want to clear storage. Again, this is just for debugging time. And you see, DevTools are not in a good form again. So we definitely want to see 0, 0 here. But refresh. Aha, we have the first message saying application is offline ready. Nice. This is what we want to have. Again, please don't do this in form of alert. Maybe you might want to skip this message completely, or please keep it as like subtle as possible. This is not something like really breaking to interrupt user experience. So this is purely for demo purposes. Good. Application is offline ready. How do we show other message saying that application was updated? Well, we have to update something. Let's go back to the code. Let's change something in our index.html. Let's call this what is very visible here and will not force us to rebuild the app. So I have this button injected pretty directly in a bit ugly way, but still that works for our use case. Let's call this install super PWA. Okay. Most likely, if we just imagine we deployed this to our server, because I serve these folders like super directly. If we deployed this, you hit refresh and you never get this message about version was updated. Why? Because we have to help the Workbox to know that update happened. And how to do this? Of course, run this build again. Let's do this. Nice. If we could remember the hash sum for index HTML, then we could say that this one is different. But let's just take it as is. This one should be different, and this will be a trigger for Workbox to show this, to send this event to our code, and we can show this. Let's try it. Reload. This is interesting. Where is our message? Okay. Maybe for some reason I messed up with some you know what? I think we have to run it again, because we updated service worker. We just injected this changed lifecycle. So let's start it from scratch. Clear site data, and let's open a new tab just for the. And let's close this one. Let's open this. You know, this is live demo. Everything might happen. Good. And now we have a chance to remember what was hash sum for index HTML, 6b something. Let's change something here. Let's call this super 2 PWA for prod. Nice. What else we can do? We have to build this. Nice. Let's check if hash sum was updated. Yes, you see it's different. That should work. Okay. Super. Yes, we got this. New content is available. And now if we hit OK to refresh, we have to see this digit 2. Let's check how that works, if that works. Yes. So we solved this update issue as well. I think we out of time, and this is nice, because what's left to say is what will happen in the next session. Next session, we go way beyond the basics of PWA. And by basics, I mean application shell and runtime caching and installability. We'll check what's also possible. Background sync, when we propagate all the actions and data we did offline automatically when we go back to online. Fetch, this is how we download larger resources. And also I will give a sneak peek on what's coming next to API set related to service worker. But main time we will dedicate to push notifications. And trust me, this is very interesting topic. Again, lots of demos, lots of something that can go off our control. And this is all from me for today. One very last statement. So you see that today we use exclusively everything from CDNs, both to register service worker and in service worker itself. Of course, this is just one possible option. It's a bit out of today's scope, but it's totally possible to download all these libraries to use this locally. Furthermore, we can do nice like modern JavaScript modifications of our service worker. So we can like bundlify this, we can uglify this, we can minify this. So all the tools are for us, thanks to Workbox flexibility.
Okay.
That's it, folks. Your questions.
Yeah, thank you so much, Max. So you went on and on and on. So service worker is, you are living in the service worker land.
Yes, I can talk for hours, but I have to run on my plane.
Okay. Yeah, that's fine as well. So I'm sure that will be like more questions coming up in the next session, I'm sure. As of now, maybe just one very short one from my side. Like if you look at the service worker, and this is kind of the thing that I see many teams struggling with. Whenever you make a big mistake, like a big issue, because it's just JavaScript in the end, so you can end up like really screwing up big time. So the question is it, how would you actually update? No, that's kind of a wrong question to ask. Maybe let me ask you something else. What do you need to keep in mind to avoid big issues down the road? So do you know, like maybe any particular things that kind of showed up quite a few times, which really brought you to gotchas or aha moments when it comes to service workers?
This is a very good question, and there is no simple answer for this. Definitely, you don't want to go and ask your users, like all millions of users.
Like go and clear your data.
Please, folks, first find this dev tools, then find this. No, I would recommend to go for service worker kill switch. So this is something that it's really makes sense to always keep available. And then what you do, you just rename your like production service worker to this kill switch service worker, which is doing pretty much something like this. So first, yes, you can easily find this. Tries to wipe all the caches. It tries to deregister itself and like start the new life from scratch. This is a very good question because it might sound simple. Okay, just remove service worker and your application is regular now. Not a progressive web app for some period of time when you have the chance to fix everything. No. If you implemented all this, for example, application shell, what you removed the registration of service worker from your main JavaScript code or from index.html where you register this. In the normal case, this index.html or your main JavaScript bundle will be served by existing service worker, which is
that's what happened to me once.
From cache storage. So your the client, the browser of your user will not see this change at all. So this is more or less chicken and egg problem. What to remove first, to remove next, to remove first again. The simple answer is you have to physically rename service worker file to this kill switch service worker. You start the new life, and then you have some time to resync to fix your errors.
Okay. That's good to know. That will help me. Actually, the fact that as of June 2018, all evergreen browsers will by default ignore the cache control header when checking for service work updates. It's something I didn't know, so that's very useful to know as well. But you know, we're totally out of time, and I'm sure that some people actually want to finally go to their parents and loved ones and dogs and cats. How is your cat, by the way?
I did have one question about
here we
Lighthouse,
go.
but it looks like we're going to talk about that next round, so I'm
Yeah.
not going to waste any time about that.
Okay.
Nice.
So, Max, I hope you're going to enjoy this wonderful evening and have a good trip. And for all the wonderful members and guests and people who happen to read Smashing Magazine as well. So thank you so much for watching. Watch out for the updates coming up on Slack and coming up on Twitter at Smashing Members. We have a few new announcements coming up soon. With that in mind, I hope you enjoyed it, and I hope we'll see you soon. And Scott,
we have another webinar, the fabulous Vidium and Vitaly video show.
That's correct. We have a little new. So essentially, we have a new show, new episode of the show coming up in 2 days, highlighting some of the news of what happens in this wonderful web industry of ours and what we, as designers and developers, have to do with it, and what does it mean for all of us. Okay, so everyone, thank you so much. We'll be publishing this video, and we'll also be preparing a transcript and publishing it very soon. See you next time.
See you, folks.
See you.
Okay.
Bye-bye.
Bye-bye.